This is a cheap and simple way to get pupils in schools making the kicking wire demonstration for themselves so they can see how the wire moves when it's carrying a current in a magnetic field. This uses a D cell. The important thing is not the size of the cell but the fact that it's an alkaline cell. Do not use a rechargeable cell for this because rechargeable cells have a very low internal resistance, and so a very large current can be drawn through a setup like this, which is essentially short-circuiting the cell for a very short time. 2 wires with crocodile clips on the ends. Those wires are clipped onto paper clips, basically a 5cm paper clip which has been unfolded to make a support. Then that support has a piece of electronics wire bent into a kind of a U shape on it. It's just this electronics wire. It doesn't have to be insulated. It could be bare, but it does need to be single core, not multi-core wire, so that it can keep its shape. The paper clips are held on with a rubber band. This is an upside down pint plastic cup. And then I have on top a neodymium magnet. You might just be able to see through the plastic that there's another paper clip. So the way the neodymium magnet is held onto the base of the cup is by magnetism. As the steel paper clip is put in from underneath, the magnet's put in from on top, and the two attract each other, or rather the magnet attracts the paper clip, if you like. When I hold the ends of the wire here, you should see the electronics wire click to one side, so it's moved towards us with the plus on the right hand side here. I'll just try and stop it moving. Turn this around so the plus is on the left hand side, and now it should kick away from us. If I turn it sideways on, it might be more obvious which direction the kick is going. So this one should kick away from us. Oh, sorry, to the right. Now I've turned it around. And if I move the battery the other way, try and stop the thing moving, it should kick to the left. Also, of course, if you take the magnet off and turn it the other way up, then that was just my battery dropping on the floor. Then you should get the opposite direction of kick for the same direction of current flow. So now, it's a bit fiddly. But my problem is mainly that my elastic band's a little bit loose. So if your elastic bands are a bit tighter than mine, it shouldn't be quite so loose. So plus is on the right here. Now it's kicking that direction. If I turn it around, plus on the left, it should kick to the left. So just to go through the equipment, just a short piece of wire, 2 leads with crocodile clips. This is the shape of the support that the paper clips are bent into, and the neodymium magnet, again the way that I held it on, placing the magnet there and dropping the paper clip into the bottom. You could hold it on with a small blob of blue tack. There's a safety issue with neodymium magnets as well. Please watch my video about using neodymium magnets safely. Please make sure you make a risk assessment, and a rubber band. One that was slightly tighter than this would have been better perhaps for this one. Okay, please also watch my video about making a motor using this setup. A very quick, easy and reliable way to get students building an electric motor. One last thing to say, if you have any problems, a bit of sandpaper, cleaning the contacts, so cleaning this area where the wire hangs, cleaning where the crocodile clips clip onto it, cleaning the battery terminals and indeed cleaning the wire itself where it makes its connections, or cleaning the crocodile clips when they make their connections will help. Thank you.